Hello everyone, welcome to the last unit in solving quadratic equations. Fairly short unit we're working on, but a very important unit. That's why it needed to be separated. We're going to use the quadratic formula in this case, and it's not something you have to memorize. It's something you're going to just work with quite often, that you'll probably end up having it memorized. But it's kind of a way of doing a shortcut method instead of completing the square, which is why I said in lesson 2 using completing the square will probably be your least favorite option in this unit. And I agree. Most of the time when I'm solving quadratic equations, I choose to either factor first, and then if I can't factor, I'll use the quadratic formula. It will give you exact value answers just like completing the square with a little less work. It does involve a little bit more calculator work though, and punching it on your calculator and simplifying radicals, but you needed to do that in completing the square anyway. So I tend to use this most often as well, but I also know that it is very important to be able to complete the square, because there are cases where you have no other option. So with the quadratic formula, all you have to do is write your equation in general form and make it equal to 0. So ax squared plus bx plus c equals 0. Take the values of a, b, and c and put them in the quadratic formula. So you do a substitution and then just simplify the formula. So let's do 4 examples here. Example number 1. X squared plus 4x plus 2 equals 0. Again, if I could factor, I will always try to factor first. But if I can't factor, then like I said, have it equal to 0, work with the quadratic formula, simplify. So a equals 1, that's the coefficient of the squared term. B equals 4, that's the coefficient of the x term. C equals 2, and you use this formula. X equals minus b plus or minus b squared minus 4ac. Take the square root of it over 2a. Now it's not an easy formula to work with, but it is a substitution, and I'll give you a little advice on how to do this substitution. You do it all in one step, you may get lost. So this is how I do this, and what this is to give you the values of x. It's a shortcut formula. So we'll put in b, so it's going to be minus 4 plus or minus, and it's going to be 4 squared minus 4 times 1 times 2, all inside the square root, over 2 times 1. Now, I tend to work out what's inside the radical sign, simplify that to a single number, because I'm going to probably leave this as an exact value 9 times out of 10. Most of the time I will not give the decimal answer. Not saying you won't do that, but most of the time you'll want to leave these as exact values unless you're dealing with some sort of application type question. Then we tend to evaluate. So if you were to just punch in on your calculator 4 squared minus 4 times 1 times 2, you should get in there basically root 8. So x equals negative 4 plus or minus, and you could work this out in your head, root 8 over 2. I always simplify it to this stage first before I either punch it in on my calculator and get a decimal answer, or simplify it and leave it as an exact value. Simplify what's inside the radical sign, which is what we call the discriminant, to a single value, then simplify further. Now root 8 can be simplified further, so I'm going to do that. Negative 4, root 8 can be written as root 4 times root 2. So I'm going to write this as 2 root 2 over 2. Now what this also means is I can divide each term in the numerator by 2. So my final answer can be simplified even further. Negative 4 over 2 can be written as negative 2 plus or minus 2 root 2 divided by 2 can be written as negative 2 plus or minus root 2. You can punch this in on your calculator. You can go -2 plus root 2, get a decimal answer. -2 minus root 2, get a decimal answer. These are fairly difficult to check because of the fact that these are not integer answers. These are radical answers, which is the whole reason why the quadratic formula is needed. If they were going to be integer answers, then it would be something that could be factored. For those that can't be factored, that means we have rational and irrational answers. So there's example 1. Get it in the quadratic formula. Ax squared plus bx plus c equals 0. Plug in a, b, c into the formula. The neat thing we could do is we can also start to look at some of the other types of questions. We dealt with a rational in lessons 1 and 2. Well, we can also come back to those fancy little radical type equations, and we can make them a little bit more complicated as well. So I have the square root of 6x minus 4 equal to 3x minus 1. Well, what we would do to solve these is square both sides, and we'll be left on the left side with 6x plus 4. On the right side, we have to square this. So you square the first to be 9x squared. Multiply them together and double it, which will give us negative 6x. And square the last. Minus 1 squared will be plus 1. Simplify further. So we're going to be left here with 0 equal to 9x squared minus 12x, and 1 minus 4 gives us minus 3. Notice this can be divided by 3, so I am going to simplify this. Divide everything by 3 to give you 3x squared minus 4x minus 1. By the way, if you didn't do that, you would still get the same simplified answer. I just want to work with the smallest values of a, b, and c. But if you did it with the 9x squared minus 12x minus 3, you would still end up with the same result. You just have more simplifying to do. So b is -4, c is -1. So do whatever you have to do to your equation. Could be radical, could be rational, could be just a quadratic. They're all fair game now that we know how to solve all the different types. Once it's a quadratic, you now have 3 methods of solving quadratic: factoring, complete the square, or quadratic formula. You can see why this will be such a popular unit in Pure 30. You'll be using quadratic formula or quadratic solving skills to solve many, many different types of problems. Plug it into the quadratic formula. X equals minus b plus or minus b squared minus 4ac all over 2a. Do the substitution. X equals minus a -4 will be +4, plus or minus -4 squared minus 4 times 3 times -1 all over 2 times 3. Again, simplify what's inside the radical sign. So I'll punch this in as -4 squared. Well, that's 16 minus 4 times 3 times -1 should give you root 28. So we get 4 plus or minus root 28 over 6. Root 28 can be simplified. So x equals 4 plus or minus, it could be root 7 times root 4. So 2 root 7 over 3. Over 6. Now you can still reduce this a little bit further. Notice I could divide the top and bottom by 2. So x can be equal to 4 over 6, which would be 2/3. So divide by 2, plus or minus root 7. 6 divided by 2 is 3. So I'm reducing. Just remember, when you're reducing the radical, you have to reduce every term on the top. Otherwise, you do not do that step. All right. So here we started with a radical equation, which after squaring both sides turned out to be a quadratic. Once we had the quadratic, put it into the formula, simplify. Again, if you wanted to find the decimal answers for this, you'd go 2 plus root 7, divide that answer by 3. There's one of the answers. 2 minus root 7, divide that answer by 3, would give you the other answer in this case. So you can even see some other types of questions. Example 3, we're going to now look at a couple word problems, and a lot of the word problems can be done either with factoring, or if they get to be really complicated or really big numbers in a lot of cases, you can just probably use the quadratic formula and then punch it in for a decimal. Most of the time, you're usually asked to give your answer to the nearest tenth, hundredth, or whole number, so you won't be looking for exact values anyway. So you can go and put these in the quadratic formula, simplify, and then just punch them in. You don't even have to worry about leaving them in radical form. So in this case, we have a rectangular playground measuring 40 by 20. It's to be doubled in area by extending each side by the same amount. So what we're going to start with is a fancy little rectangle that's 40 meters by 20 meters. Now that has an initial area of 800 meters squared. What we're going to do with this thing is we're going to extend each side by the same amount so that we end up with a bigger rectangle. So it's going to be 40 plus some amount by 20 plus some amount. And what we want to do is we want to double the area. Well, since we know what the initial area is, we know that this final area will be double it, so 1,600 meters squared. So what we want to do is figure out what the new dimensions are, or how much each side should be extended. So let's let x equal the amount of extension. Now let's build our equation. Well, we know area is length times width, so we can go 1,600 equal to 40 plus x times 20 plus x. Let's punch everything in. 1,600 equals 40 times 20 is going to give us 800 plus 40x plus 20x plus x squared. Since this is a quadratic, let's set it equal to 0. So 0 equals x squared. I'm going to write it in the proper form. I've got 40 plus 20, which will give me 60x. And I have 1,600 when I take it to the other side. So 800 minus 1,600 will give me minus 800. It's a little bit big numbers to work with. So what I'm going to do is, rather than try to play factoring, finding two numbers that'll multiply to 800 and adding to 60 could take you a while, we can just put this into the quadratic formula. Now that we know we have a quadratic, we set it equal to 0, find a, b, and c. So I haven't done any solving using the quadratic formula. The first thing that I've done, or all these steps here, was just a matter of setting up the problem. starting with my playground 40 by 20, 800 meters squared, doubling its area by adding some value of x to each side, creating an equation. I'm going to write that equation on the next slide. So we had x squared plus 60x minus 800 equals 0. Pull out a, b, and c. A equals 1, b equals 60, c equals negative 800. Put this in the quadratic formula. Minus b plus or minus b squared minus 4ac all over 2a. Do the substitution. X equals minus 60 plus or minus 60 squared minus 4 times 1 times negative 800 all over 2 times 1. Simplify that discriminant, or what's inside the radical sign. So you get negative 60 plus or minus. So I'm just going to punch this in on my calculator now. 60 squared minus 4 times 1 times negative 800 should give me square root 6,800 all over 2. Now I'm just going to load up a calculator here to show you how to punch this in. Just to make sure we're okay with it. So I'm going to punch in here negative 60. And I'm going to do this in 2 steps. I'm going to punch it on here, and then we'll put the answers down after because I don't want to lose my slide. So it'll be negative 60. And we're going to go plus square root. I'm just going to move this over a little bit. 6,800. Don't forget to close your brackets on the square root. Now I tend to hit enter after this stage just so that I work out the numerator. And then I'm going to divide that answer by 2. So divide 2, and I get 11.2 to the nearest tenth as one of those values. So x equals 11.2. There is another answer, so we should punch that one in as well. We'll get negative 60 plus, or this time it's now going to be minus square root 6,800. Again, I close the bracket and hit enter. And now I divide that by 2. And this answer is negative 71. Well, the answer of negative 71 doesn't make sense. You can't add a negative distance. So there's one answer that makes sense in this question, the 11.2, and a second answer that doesn't make sense, the negative 71. It wouldn't be an actual true solution. There's always 2 answers to quadratics. Just sometimes one of them is an extraneous or is a solution that doesn't make sense to the problem. So I just wanted to kind of show you how to punch those in on the calculator, making sure that you can evaluate these radicals as well. I'm just going to hide the calculator again. Let's write our 2 answers down. X equals 11.2 meters, and the other one was, I'll have to go back to the calculator. Negative 71.2. Or x equals negative 71.2 meters. Now I tend to always cross this out and write ext, meaning it's an extraneous solution. It doesn't make sense for the problem. So again, what did the question ask? How much are we going to extend it? The dimensions will increase by 11.2 meters. And you could definitely punch that in. Now it won't give you an exact value, but you could go 40 plus 11.2. If you wanted to just check, 40 plus 11.2 gives you one of the dimensions as 51.2. 20 plus 11.2 gives you 31.2. So 51.2 times 31.2 gave me 1597.44. Now the reason why that wasn't exactly 1600 is because the answer wasn't 11.2. We rounded it to 11.2. So when you check, you'll have to realize that you're putting in a rounded value, so you'd have to see that your answer was close when you did a check. But it should check and make sense for your questions. So notice that would have been a fairly difficult one to factor. In fact, it's an impossible one to factor because it doesn't work out to be integer answers anyway. So you use the quadratic formula. You could have also completed the square, but this is a little bit faster. So these types of questions, geometry, are very common. The other type is back to those distance, rate, times that we did before. So the distance from Winnipeg to Billings, Montana is 1,200 kilometers. A moving van made the round trip in 31 hours. The average speed from Winnipeg to Billings was 5 kilometers an hour slower than the average speed of the return trip. What was the average speed from Winnipeg to Billings? So again, what we need to do, start with our trip there, and then we have a return. Now let's set up our chart that we used to do back in our previous units. Nothing changes. Distance, rate, time is still what we're chasing here. Let's fill in what we know. The distance there is 1,200. The distance back is 1,200. They do give us a total time, which tells us once we know the times, we can add them together. They give us a relationship between the rates, and we're supposed to find speed. So we know that the average speed from Winnipeg to Billings was 5 kilometers slower than the return trip. So the return trip was faster, x plus 5. The original trip there was x. If we want, we know two columns, and you build the third using the formula. Distance equals rate times time. So time equals distance divided by rate. So this column will be 1,200 divided by x. The last column will be 1,200 divided by x plus 5. You've set up these problems already back in our rational equations and linear equations and our systems of equations. Dealt with lots of distance, rate, time. Now you're going to deal with distance, rate, time that'll simplify to a quadratic equation somewhere along the line. We're supposed to define our variable, so let x equal the speed there. X plus 5 will be the return speed. And let's build our equation. The total time, round trip means there and back, was 31 hours. So that means we take the two times, 1,200 over x plus 1,200 over x plus 5 gives us a total time of 31 hours. Since it's a rational, multiply by the common denominator, just like we've done in the past. So the x's divide out in the first term, leaving you with 1,200 times x plus 5 plus 1,200 x plus 5's divide in the second term, leaving us with just 1,200x, equal to 31x times x plus 5. Expand. 1,200x, 1,200 times 5 will give you 6,000. Plus 1,200x equal to 31x squared. 31 times 5, we're going to need some calculator help, plus 155x. So we're working with some really big numbers. You can see why we don't want to use factoring for something like this. Let's collect everything. Let's make this 0 equals 31x squared. We have 155. We have 1200 plus 1200, so we're going to go 155 subtract 155 subtract 2,400 to leave us with minus 2,245x, and our constant term will be minus 6,000. I always move my terms to make my squared term positive. I always like a being positive. Doesn't matter really when you've substituted in, the signs will take care of themselves, but I always like to, just in case it's something that I could factor. You could spend a couple days trying to factor this. You may not even find it that it's factorable, so we're going to use the quadratic formula right away. You get really big numbers to work with. Don't try to factor it if it's not easily factored. Then use the quadratic formula. So just to recap before I go and use the quadratic formula, I'm just going to jot this equation down on my paper in front of me. 31x squared minus 2245x minus 6,000. Set up the chart. Filling in the information. You know you need 2 columns to fill in. There's going to be a relationship between either distance, rate, or time. Then use that relationship. Then they're going to give you a total or a difference somewhere in that question and build your equation out of that. Since this simplifies to a quadratic and not a linear or another rational, we've got to simplify it and solve it as a quadratic equation. So on the next slide here, I will finish this off. X equals, 31x squared minus 2245x minus 6,000 equals 0. A equals 31, B equals negative 2245, C equals negative 6,000. Now the question will just want us to give the speed, so which will go to the nearest whole number. Minus b plus or minus b squared minus 4ac all over 2a. Substitute everything in. Minus a negative 2245 should give us a positive 2245. Plus or minus negative 2245 squared minus 4 times 31 times negative 6,000. It's an ugly one, which just means we're going to use our calculator, over 2 times 31. Simplify it. 2245 plus or minus. Alright, now we punch in the 2245 squared minus 4 times 31 times negative 6,000. We get a really big number, 578 4025 over 2 times 31, which would be 62. Now punch it in. So we'll go 2245, just like I was showing you on the calculator. 2245 plus second function square root 578 4025, close the bracket, enter. divide by 62. So you get 4,650 divided by 62 gives you 75 kilometers per hour. This could have been factored. Would have never figured that factor out, but it could have been factored because it divides out nicely. The other solution is 2245 minus square root 5784025. Enter, you get negative 160 divided by 62, and you get negative 2.58 kilometers per hour, which doesn't make sense. So we'll cross that one out. That doesn't make sense to the question. Now that was the speed there. X plus 5 is our return speed. So that was 80 kilometers per hour. Now if you go back to the question, what you were being asked, it says, what was the average speed from Winnipeg to Billings? So we're going from Winnipeg to Billings. Moving van average speed from Winnipeg to Billings was 5 kilometers an hour slower than the return trip. So Winnipeg to Billings was the slower one, be 75. The return trip was 80. Now remember, it takes 31 hours total. So if we know the speed and we know the distance, we could do a very quick check if you wanted to. We know it's 1,200 kilometers divided by 75. 1,200 divided by 75 gives you 16 hours. We also have 1,200 return at 80. So 1,200 divided by 80 gives you 15 hours. When you add those two, you get that total they were talking about in the question. 31 hours. So we can state the average speed. Speed is 75 kilometers per hour. And that was the average speed there. You could have been asked for speed there, speed back. Answer the question, whatever you're being asked. So even when you get some nasty ones, doesn't matter. I'm not going to ask you to simplify this kind of question and leave in radical form. This will be one where you'll just evaluate using your calculator. So the key is turn it into a quadratic, set it to 0, plug A, B, C into the formula, simplify the radical, then just kind of punch it in on your calculator if needed. Work on the 20 questions in lesson 3. Once you finish that, you'll have a short self-test and actually a fairly short exam. For this unit, since there was only 3 topics, your exam and self-test won't be the same length as some of those other ones. Unit 4 of 5 complete. Take care, everyone.